Applications of density. For that, we need three vocabulary words, which would be mass, volume, and of course, density. And here's a setup equation of how these three vocabulary words relate to each other. So we have mass to be the total amount, which that could be weight, population, or just a value. We have volume, which would pertain to amount of space covered, and density, a measure of how much mass there is in a given amount. So this is our equation that it's created using these three vocabulary words. So density equals mass divided by the volume. So we can know here the density is just the ratio between mass and volume. Now, on this first exercise, I'm asking you the following. So on the following list of words, circle the words that pertain to mass, and what's the words that pertain to the definition of volume, amount of space covered. So here I'm going to break the rules a little bit on the precise definition of volume, because volume usually refers to three-dimensional objects, and you would typically have a unit of measurement raised to the power of 3. But in this case, just for the sake of this lesson, volume will also pertain to area, surface area, or just area in general. So the ones that I would circle that would pertain to mass. So mass would be this one, all people in a city. It'll be kilograms, remember, could be weight, so kilograms is definitely weight. Number of animals could be anything. So again, go back to the definition, mass, population, so number of animals, or people in a city, that's population. Number of atoms, that's also mass. All of those are mass. So we have four for mass. So number of atoms, number of animals, all people in a city, and kilograms. Now for volume, there'll be square centimeters, cubic millimeters, cubic feet, and of course square miles. Nice. Now that we have kind of defined these vocabulary words, let's go on to how to solve density exercises. So the first step to solving density exercises is to identify which pieces of information refer to mass, which refer to volume, and which refer to density. We will usually be given two of these three pieces of information, and we're supposed to find, of course, the missing piece. Now the second step is to set up an equation where mass is divided by the volume. Alright. Then we have to divide both volume and mass in such a way that the denominator, volume, becomes 1. So here's an example of that, where we have density equals 30 people, so that's basically the mass, divided by 0.5 square miles. That's your volume. Now here's the tricky thing. You have to solve this in such a way that the denominator, 0.5 square miles, becomes 1. So the question would be, what can I divide to 0.5 to make it 1? So what do you divide to a number to make it 1? Divided by itself. That's why I'm dividing here. I'm dividing the bottom by 0.5, and what I did to the bottom I also did to the top. So I also divide the numerator by 0.5. 0.5 divided by 0.5 gives me 1 square mile, and 0.5 divided by 30 gives me 60 people. So my density equals 60 people per square mile. Same with this one, the second example. I have density equals 300 people divided by 15 square miles. What can I divide by 15 to make it 1? Well, 15 divided by 15 gives me 1. So 15 divided by 15 gives me 1 square mile, and 15 divided by 300 gives me 20 people. So the density is 20 people per square mile. Now here on the following piece of this worksheet, I have given the set of values, set up equations to solve for the missing value. And so we're given the volume on this side, we're given the mass on this side, the density on this side, and here's where we want to write our equation and of course solve the equation. So for the first one, we're given 70 square millimeters with a mass of 7,000 of bacteria inside those 70 square millimeters. We want to find the density. And so for the other one, we have 200 cubic feet and 600 liters of water. So there's 600 liters of water and 200 cubic feet. We want to know the density. So we want to know how many liters of water there are per cubic feet. Then we have, well, the rest of them are really similar. I'm gonna go over a few of these. So let's go back. Let's go onto my notebook. All right, so the first one, it was 70 square millimeters. That's one piece of information. And the other one was 700 bacteria. It's 7,000 bacteria, sorry. I'm gonna set up these two pieces of information as the equation. Remember that the equation I gave it to you. So it's density equals, we have the mass at the top. Remember, the mass will refer to the total amount of, could be population, could be mass, could be weight. So we're gonna have 700 bacteria, 7,000 bacteria at the top, divided by 70 square millimeters at the bottom. This will give me, I can divide my bottom by 7 and divide my top by 70. So here 70 divided by 70, that gives me 1. And 70 divided by 7,000, that gives me 100. My answer in the end should be 100 bacteria per squared millimeters. This should be my answer. For the answer, I don't want to see just the 100. I need to see what the 100 means. And in this case, the 100 means 100 bacteria divided by, well, 100 bacteria per square millimeter. All right, now I'm going to do another example. So for the following, number 2, it's pretty much the same setup, everything, but I want to touch on to either number 3 or number 4, where instead of being given a mass or a volume, we're given the density. So we have to still create an equation, but solve for either mass or volume. So I'm going to do number 3. Back to our notebook. So for number 3, we are given the density. The density is 25. So 25 should be equals to my mass up here and my volume down here. So let's see the volume. It's not the volume, it is given to us. The volume is 150 square meters, and the number of people, we are not given the number of people. We're giving x for the number of people. We don't know how many people there are. I want to know how many people there are. So here we basically are trying to solve for x. So how do I solve for x in this particular example? I can just multiply both sides. 150. So the 150 and the 150, they divide out to 1, so we're left with at equals, now 25 by 150. 25 times 150, that's equal to 3,750. So number of people, total number of people, that should be 3,700 of people. 3,715. Okay. So with that, you can basically solve the last two problems, which will be number 2 and number 4. Now, just to wrap it up, I'm going to help you solve one of these. I'll help you solve number 2. Number 1, I really want you to try number 1 because it has one extra step, so I want you to think about it. So I'm going to do number 2. It says a country has an area of 135 square miles. If the population density of the country is 65.1 people per square mile, how many people live in the country? So we're given two pieces of information. We're given 135 square miles volume, and we're given 65.1 people per square miles. And you can actually see here if you read it. The density of the country. We're given the density and we're given the volume. We have to find mass. So let me set up my equation with this given values. So my density 65.1. Density 65.1 should equals, again, my mass, my volume. The volume was 135 square miles, but we don't know the number of people again. We don't know the mass. So again, like the other one, multiply both sides by 135. Multiply both sides by 135. 135, they divide out. So my answer, x equals 8,788.5. Now, my complete answer for this would be that 8,788.5 people live in this country. And that's pretty much it. Everything will revolve around this particular equation, and just finding either one of the three variables given to us. Those three variables, so we have density, mass, and volume. We'll be given either density and mass, and we'll have to find the missing variable. And that's pretty much it for this lesson, applications of density.